workshop. So Peng, you can go ahead.
All right. Greetings, everyone. I think let's just probably give like 1 more minute just for people to settle in. So today I'm going to be walking through like the process of like setting up a production GPU from scratch on your own. And I'm going to like jump into like why and probably why you should need to do this later on. But yeah, that's what we are going to be doing today. And this is mostly going to be like an interactive session. I did not like pre-record anything. I want us to like go through the process. So like you guys see me like trying to fumbling or probably like trying to like set up everything up to when I have like the GPU server set up, or I even have like the Jupyter notebook ready to like write some code into it. And so as I'm going through that process, I want it to be like interactive. So I'm going to be checking the chat. I don't know how frequently, but I'm going to be checking the chat. Sorry. So feel free to like ask a question, technical, probably logistic question. I think it's mostly logistic. Maybe Kevin and Regina will probably help me, but like feel free to like ask your technical questions, and I'm going to answer to the best of my knowledge. And if you need to like push it to like another hackathon, so another workshop, then definitely I'm going to like give you insights on how to like how to like probably tackle it, or how to like or to answer the question later on. So I guess we can start now. So just checking the chat if there's something. No, I think that's fine. Yeah. So I would like to start up with a question. Can any of you like can you briefly list any GPU service? Like I know you guys are like into AI, or AI has been like a lot on the media. So I'd like to know like what platform have you guys used to like train your models? Feel free to like drop in the chat, or you can like raise your hand and I'm going to like just call your name and you can speak out, and you can probably like tell me why you used it. All right, collab. Robo, okay, I know of RoboFlow. Okay, Kaggle. Kaggle. Okay, seems like Kaggle is winning for now. I haven't trained any model before. I use MCP. Okay, Collab, Kaggle. Okay, seems like Collab and Kaggle. Lightning AI. I've heard of it, but I've never used it. Okay. So okay, I'm mostly Google Colab. So just to start, like I maybe I'll have prepared some slides, but that's fine. So just to start, like I see a lot of people have used Google Colab. A lot of people have used what's the name again? Kaggle. Some people use SageMaker, but I know SageMaker is usually like very expensive. And today I'm going to be showing you guys like how you can train a model on a budget. So like you must not, because I know you can like use and Google Colab or Kaggle to like do like a good, they have like some free tier which are really good. But if you want to like push above that free tier and probably like train something for like let's say an entire week, I think on the like the main thing is cost. I feel like personally, I know that stuff like Kaggle or Google Colab, you don't have like they already like set up the Jupyter notebook for you, and so you have to be paying like extra dollars just for the convenience of like they already have like a ready to use GPU, or sorry, a ready to use Jupyter notebook. So when you use like when you actually go to like a server provider and set up your own server that has a GPU behind it, for most of the cases, especially when you want to like go above, like push the limit of the model. I'm not saying like you're going to build something like ChatGPT, but you want to like create something that is going to be like above what people usually see, and just like slightly advanced. You have to like, I think for it, like if you're really on cash constraint, ideally you want to like set up your own server, because in the long run it's going to be less costly. You're just going to be paying for the cost for like the server and managing the server, and you won't be paying for like the convenience of like just like pulling up the just going to like Google Colab and creating a new collab. And yeah, so that's really why I wanted us to like have this hackathon. I'm just going to stop sharing this screen now and just share my entire screen. So that's why we have this hackathon. So I'm just going to start going through what I have planned. So the process, the goal is we are going to go through like these steps. Hopefully you guys have had some time to like go through it, but I drop a couple of links here for you to like start navigating. Like maybe I don't know if you have any question, feel free. But I drop a couple of links here which you can reference. And we also have like a GitHub repository with all the starter code which I'm going to use. There's nothing much for this workshop. The next workshop is going to contain more starter code. So yeah, feel free to like check the GitHub repository and also check this document, which you have access. The link to this document, you can find it on the Notebook LLM. This is it, Ghana AI Hackathon. So some options I really like to use. Number one, DigitalOcean, Vast AI, Runpod. I think they are kind of like on the inexpensive side. Like they're not like crazy like GCP, Google Cloud, Amazon, or probably like let's see what else, Kaggle. I think Kaggle is good. Like their free tier is very generous, but I think to run some stuff you might struggle a lot. But I like depending on your use case. Sometimes when you really want to like push higher than the free tier, or you want like something to run fast, it's usually best to probably like pay $50 for like a super gigantic GPU, run your training for like let's say 10 hours, and then shut it down like immediately. So like that's why I'm trying to walk you guys through the process. So feel free to check out Vast AI, Runpod, and you can also check this Reddit post. I think they usually up that a lot of people that suggest a couple of things there. Yeah, so you can probably keep an eye on this Reddit post. Like this is what people usually use. So, but for this tutorial, or for this workshop, we are going to be using DigitalOcean. So I don't know if anyone has heard of DigitalOcean, but DigitalOcean is something like Google Cloud, and they have like servers which you can set up easily. I would say it's a little bit less expensive as compared to like GCP or Google Cloud or Amazon Cloud. So feel free to like check it out. But most of what I'm going to be demonstrating with like DigitalOcean is going to be slightly similar to Vast AI or Runpod. You just need to probably like go to their website and see how to like create a server for yourself. So hopefully you guys can still see my screen. So I have already logged into my DigitalOcean account, as you can see. And what I'm going to do is I'm going to create a new server. So I'm going to come here, and if it's like for like different cloud providers have their own way of like calling like a server. So it's been so long I use Google Cloud. I've forgotten how Google Cloud called theirs. And then Amazon called theirs. I forgot. Oh my god. I've forgotten the name Amazon called their own server. If anybody knows it at the top of their head or the mind, they can just say it. Why have I forgotten? It's something. But yeah. So in DigitalOcean, pardon.
AWS.
Yeah, AWS. They have a name they call their servers. I've just forgotten the name.
Oh, okay.
Yeah, AWS. Is it? No, it's not long. AWS server. Okay, it's EC2. Yeah, AWS is EC2. So like it's just a machine. Like each cloud provider have a way they call their server, like the server they use. So for Amazon is EC2, the common one. So I was just saying that I just wanted to bring that analogy because on DigitalOcean you have like Droplets. Droplet is just a server, and that's how they call it here. They have a couple of other options, but we'll not dive into it right now. So if you can see, we have GPU Droplets, which I think they added support for it at the top of the year, or probably like at the end of 2024. So I'm going to click on that and try to like create a GPU server. What I usually use when I want, like, if you scroll down here, let's just pick here. So here you choose like the region you want the server to be located. Let's just leave the default region. The OS, DigitalOcean has like their AI ML ready GPU server. So it means like what, like instead of like if I click on Ubuntu, right? Ubuntu is just going to come like a bare Linux server, which you have to install a couple of dependencies. Like sometimes it's usually tricky to like get the like install the dependency, the right dependency for your GPU. But I don't know if you're used to Linux, you should be easy. It should be easy for you. But I think most of these cloud providers, they already have like an AI ML ready solution where the server already has most of the GPUs already installed. As you can see, Linux bundle with required GPU drivers. So ideally, you want to click on this. So this is the image we are going to be creating. Now they have a couple of options for like different GPU servers. And yeah, they have a couple of options. So I think the most powerful here is usually like on DigitalOcean, from what I've seen, it's usually like the H100, if you guys have heard of it. But we are not going to be using these just because we don't want to run like anything very like big for now. Later on during like the bonus workshop, we are going to be like giving you access to like an H100 for you to run your training workloads. We're going to give more details on that. So for this workshop, oh, they don't have it for, like, I want us to use this L40 GPU server because it's kind of cheaper, one GPU. So it seems like in this region, we don't have it. So I have to select something like, let's try Atlanta and see if there is, okay, it's not available. Let's try Toronto. Okay, it's available in the Toronto data center. So this GPU is like not as powerful as this. As you can see, this is like 8 gigabyte of RAM, 20 virtual CPU, and 250. Well, I think this is just a percentage. I'm not sure what they mean by 250 gigabyte of RAM. What is this? I'm not sure I understand. Yeah, probably need to like look more into this, but I'm not sure what they mean by this is virtual RAM. Okay, the virtual RAM and this is the RAM. I'm not very sure, but that's fine. So I want us to use this. This is like a single GPU, 48 gigabyte of virtual RAM and 64 gigabyte of RAM. And then the storage is like 500 gig. So I don't think we need backups for this. Well, it's free. Let me just toggle it. So, oh, it's no longer free. Okay, I'm just going to disable it because we don't need backup. So usually DigitalOcean takes like a backup of your server, and normally this is supposed to be free. I used it last time and now seems like it's not. Weekly backup, each backup is kept that. Okay, the backup, well, let's just disable. We don't need it for this server. So additional storage, we don't need this. So usually when you create a Linux server, you usually want to like authenticate through the, like that's usually there are two options you authenticate to like get access to a server that is online. Since this server is private, like the server is located in Toronto data center, in DigitalOcean Toronto data center, you need a secure way you can connect to that GPU instance without it being like easy for people to use or to access. So one of the ways is like SSH keys. I think I dropped a link for more information on SSH keys, maybe not, but you can just Google it. It's just a secured way of like, I closed that tab, I wasn't supposed to do that. It's just a secure way of connecting to, no, that's not what I want. It's just a secure way of connecting to a server. Trying to pull up that doc. So because there's some links there, yeah, this is it. Yeah, so GitHub has a good tutorial on, okay, see, well, DigitalOcean, okay, the link I added was probably like DigitalOcean, but they have like a good tutorial that explain what SSH is and why you should use it. And this is like, I think this one, like one of the most secure way of like setting up a connection to your server. So these are SSH keys I've already added. So I think on which laptop am I? This is, yeah. So these are different SSH keys I've added. So when I click this, the goal of SSH is like this SSH is being saved on my PC. The SSH key and the public key, is it the public key? Which one is being saved on the server? Might want to read more on that. Yeah, Bright, 1 second. Let me just I'll get your question. So the SSH key is being it's being saved on your server and on my local machine. And what is going to happen is when I try to authenticate from my local machine, it's going to check the public and the private key and see if they match and then give me access to it. So this is free, so I'm just going to enable it. I don't think we need much here. Let's say workshop 1. And yeah, I think that's it. So just checking the cost here, it's $1 per hour, $1.5 per hour. And I'm going to start creating it. And then Bright, I think you had a question. So this is going to take some time. So yeah, Bright, can you go ahead?
Yes, please. Is the recording going to be made available after everything?
Yeah, sure. Yeah. I love the talk with AI. Anyone can build a model and train. Okay. Just a quick question. Maybe just how many people are on the session? 37. So I'd like to know are you guys familiar with to know to tailor my explanation to make it probably simpler? Maybe sometimes I'm diving into too much details, but I'd like to know how many people how many of you are familiar with using Linux or Ubuntu server or just anything Linux? If you can just drop it in the chat and I'll just have an idea of how many, or you can just do a thumbs up so I have an idea of how many people know, just to tailor my explanation. Probably explain more advanced stuff or less advanced stuff. All right, so we have a couple of hands. I think we had someone raised their hand. Is there any question? I think I'll take one question. The server is already ready.
Yeah, I think it was
Okay.
Calvin. Calvin raised his hand.
Yeah, feel free if you have a question. Just go ahead.
Oh no, it was a mistake.
Okay.
So, like I said, you need to setting up the SSH key. If you see I had to select an SSH key, I already added the SSH key. So when you go through that process, you just read their tutorial. So if you see how to add SSH key to an existing droplet, and you just walk through this process, it's not difficult. If most of you have already set up your GitHub to authenticate via SSH key, that should be easy. So now I'm just going to pull up a terminal on the PC or on the PC that has my SSH key, and then I'm going to log in to that server. So I'll just copy the public IP and then I come here. So for each SSH, it's usually SSH root at this. This should ask yes. So okay, now I'm logged on to this server, to this GPU server. So let's just go. So let's follow this tutorial. This tutorial is on the document. If you come to the document here, you're going to see running. No, this is it. This is a complete guide. This is a complete guide I'm going to be following now, just a reference. But we have already set up SSH key. Now we need to install dependencies. So the Jupyter Notebook dependency to give us a nice UI to quickly work on. So let me skim here. I don't know if I should walk you guys how to set up a user, or we should just use a root user. Yeah, let's just keep it simple and use a root user. So when a new Ubuntu server is being created, you have the user, which is called root, that is being added automatically, which is the administrator of the server or the main user. So you can go ahead and add some other users, but I think we'll just keep it for now because we can actually just proceed. And sometimes when you create a GPU server, most of the times when I personally create a GPU server, I have my training script and everything that I already tested locally. And then I just make sure I quickly set up the server, so I'll not have time to set up new users, install packages. And that's why you saw I picked the option that DigitalOcean already had the GPU servers installed. So it's going to like cut the time so I can go to like start running my training script as soon as possible. So right now, I have access to the server. What we want to do is to install either Anaconda or Miniconda, or you can just go ahead and install Python virtual environment. So I drop links to tutorials that you can quickly just use here and install. Personally, I usually use Miniconda because it's lightweight. I've never had a scenario where I really had to like use Anaconda because I know Anaconda has a lot more other stuff as compared to like Miniconda. So yeah, so now we have created the GPU, we have logged in as the root. Yeah, this is the step of like that showing you how it's like create a new user just in case you want to like create another user. So I'll just keep that, and then I'll just like make sure ls, where are we? Yeah, we're in the root. So I think I'll just the user, does the root have a home? I think so, or maybe not. So I'll just make a new directory. I think that's the command. Let's say test. Yeah, so I've created that directory. I'll cd into test. Cd means change directory. If there's anything I'm doing that you feel like you need me to explain better, just go ahead and like raise your hand and I'll be able to see. So now I'm in, like, I just created a directory just to save my files there. So now I'm going to install like Python, just to install like, you guys, I think everybody knows of Jupyter Lab. It's going to like give us a notebook interface. You can actually go ahead and install Miniconda. For the server we are going to set up for you guys to be running your training script, we are going to set up Miniconda. So I don't know if it's necessary for us to install it here because we are just going to be running something very basic. Let's just install it. So cd this make directory Miniconda. It's actually straightforward. Should we? I doubt. Yeah, I don't think it's necessary for us to install these because we're not going to be doing anything crazy for now. But just note that for the GPU server, we're going to be giving access. Like, I don't think you guys will need to like master a lot of these. You guys are just going to like submit a script and then we'll just like run the training job. So no need to like dive into that more. So we're just going to use the default Python environment that comes with Python. So let's just make sure we install that. So this is going to install the Python environment, and I think I'll just click OK. Now I'll clear my terminal and I'll create a new, I think this is the command, venv, env. I'll create a new virtual environment. So for someone who doesn't know, a virtual environment is like, I don't want to install the packages on my system. I want to install it probably like in this folder, so that if, like, for example, you have some project that run with PyTorch 1 point something, and then you have some project that run with PyTorch 2. So imagine if you install like all this, if you install it like PyTorch 2 on your system, and then you're trying to run on a project that requires just PyTorch 1, then you won't be able to, you have to like reinstall it on your system. So that's why most of the times we use like a virtual environment. So I'm going to activate it. So activating means anything I'm going to install is going to go into that virtual environment. And notice a change here. So now I have this folder, like this bracket around around env. This is the name of my virtual environment. So I usually just use env. You can use whatever name you want. It could be your project name. I probably would have used workshop 1, but this, like, it means anything I install through Python now is going to go into this environment. It's the same thing if we're using Conda, but for you to create a Conda environment, you would use the command, where is Conda? If we're using Miniconda or Anaconda, we'll use this command to create the virtual environment. It's Conda create. So we use this command. And then after that, you just use Conda activate, and it's going to do the same thing, which means anything I install, it's actually going to be installed in that, anything I install is installed in that folder. Let me put it like, just keep it simple. So now we have a virtual environment open. Yeah. Is there any question? Am I too slow or like am I too fast? Any feedback or comment? All right.
Let me do this. Hey, Peng, let me ask this question.
Yeah.
Type in the chat 0 to 1, 5 being you understand it is very simple. 1 saying I'm just lost. I'm lost in the woods. I don't know what's going on. He needs to slow down. And 5 is like I understand perfectly. From from 1 to 5, how do you guys feel? Drop that number in the chat.
Yeah. While waiting for that, maybe I should just draw. Or
Okay,
just
so I see a
overview.
3. We got a 3. We got a 4. We got a couple of 3s. Okay. 5. We got a 4. Okay. We got another 3. We got another 3. We got a 4. Okay, cool. So it looks like it's 3 and 4 around there. So okay, so someone is a bit lost. Okay.
Yeah, Elite Bright, can you just like ask a question, then I'll just like do an overview, trying to like answer specifically where you're lost. Feel free to like fumble, like no, but there's no like any like just feel free to like tell me exactly where you don't understand. If it's like the overall if you need like an overview or there's a specific point you want me to explain. Yeah, Elite Bright.
And feel free to drop in the chat if you're unable to talk. He said, honestly, I lost connection when I joined again. You started talking about SSH. Okay. Okay, cool.
Yeah.
So definitely, we definitely will be setting the recording so you can see what you miss.
Yeah.
So cool. So Peng, it looks like we're around at 3 to 4 right now. It looks like the majority of people are at like that 3 to 4. So, you have some people following along, some people may need a bit more support. So I think it's good right now.
Right, the corresponding private key is secured on the user system. Okay, yeah. Yeah, just wanted a clarification. Yeah, so I'll just give like a quick overview. So Bright, what we are trying to do is we are trying to set up a GPU server on DigitalOcean so that we are going to use that to train a model, to run the training of the model. And why are we doing this? We are doing this because at some point when you want to like really advance or like do something a bit advanced, using something like Google Colab, like I love using Google Colab or Kaggle for like prototyping. But if you want to run a job for, I think Kaggle caps you at, is it 10 hours? So you cannot run a job that lasts more than 10 hours. So even like something like Google Colab, and they kind of become a lot more expensive. But if you see with something like DigitalOcean, you can get a very powerful GPU. Like let's say $1.57 is much money, but imagine if you can have like a GPU to run like something that is a little bit more advanced, and that is going to take like maybe 2 hours rather than waiting like 10 hours on like on Kaggle, or just like maybe if you want to run something that is bigger. So I'm just showing you guys the process of like how you can set up the server for you to run the training. So what I was talking about SSH is also a means of authentication. You can use password authentication to authenticate through your server. So when you for example, when for you to log into your server, there's this command. Yeah. So for like this is the server which is in the cloud or in Toronto for this specific server we created. Your laptop is in Ghana. You need to like connect to this server and run commands here. For you to connect to that server, you usually use SSH, and you can either use a password or like SSH keys. So normally the way you do that is like once you run SSH root, then you append the IP of your server. So the IP address is just the unique identifier of that server online. It's just like google.com, but it's not associated to like a domain. So it does not have like a user-friendly name. So for this server, the name of this server like online is actually this number, or that's the identifier. So that's how we identify it. And then this is the way you connect to it. So if I set up password authentication, once I type this command in my terminal, it's going to ask for my password. But since I'm already using SSH, I just need to like add my SSH key. So adding the SSH key, it means that when you create an SSH key is like you have a secret key and then you have a public key. So what happens is that the public key is being saved. The public key is being saved on DigitalOcean, and the private key is being saved on my laptop. So it means when you create an SSH key, for SSH I like GitHub guide, GitHub setup SSH key. I think GitHub actually explained it a lot better. Let me see, generating a new SSH key. Oh, I'm using Ubuntu. Sorry, my current system is Ubuntu. So if you're using Windows, it's going to be a little bit different. So that's why I recommend using like the docs from GitHub, because I find it very easy to understand. So I'll just add it here. GitHub SSH tutorial, and I'm just going to add the link here. So if you're using Windows, you have to like toggle here, but I'm on Linux, so I'll just toggle it here. And when you generate an SSH key, it generates like it generates both the public. I thought they showed like an example here, but that's fine. It generates a public and a private key. So what we usually do is we copy the public key. We copy the public key and save it on DigitalOcean. So when I was setting the server, when DigitalOcean asked me to select the, I think I should try and create a new server just so you guys see. So when you try to like, on DigitalOcean, you can manage your SSH keys easily. So if I try to create another server, if I try to create another server, you're going to see there is going to be a, like I've already added like some SSH keys on DigitalOcean, but now if you want to add a new one, this is how you add it, and you just copy the public key. So when you generate this, if you read through like the tutorial from GitHub, it's going to like show you where your public key is, and it's very, well, I won't say straightforward, but you can easily figure that out, and you copy it and paste it here. So when you create now the server, you just need to select which public key, which SSH key. I feel like I need to regenerate my SSH key. But you just need to like select this SSH key that GitHub needs to, that DigitalOcean needs to add to that server. So so that's basically it about SSH key. So once you have the public key on the this server, when you type SSH root, when you type this command, SSH root at the IP of that laptop or the server, is going to now do the check. Does this server has a public key? Is it the right private key? It just does that check, and it's a way of authenticating you. So that's where we are now. We have been able to like authenticate to this machine, and then now we have set up a virtual environment, which now we want to install like the packages we are going to use. So Jupyter Lab, I think everyone here knows Jupyter Lab, but it's just going to give us like that Jupyter notebook interface. So I think there's a link there to just install it. So if we're using Conda, this is the command to install it, but we are using pip, so we are just going to use this, and that's why you see me, I have this command. So I'll just press the SSH connection doesn't usually, like for example, I've been talking for a long time. This SSH connection usually has a timeout, after which, if I do not issue any command, it just close that SSH connection. So I need to re-authenticate. After I re-authenticate, I need to activate my virtual environment. Let me just copy this command. Okay, it doesn't want me to copy, but that's fine. So cd into the folder test, source env, so has been just activate. Yeah, I'm in this folder now, and I'm just going to install Jupyter Lab. Excuse me. So like I said, all the steps are outlined in this tutorial, which you can find on the document, and just go through it. And yeah, if you're going through this process and you have any issue at a specific step, just let us know. Like, just drop it. I think we have like a question channel, so just drop it there, and we'll try to answer as soon as possible. So Jupyter Notebook has been installed. Now I'm going to try launch the Jupyter Notebook, or the Jupyter server, sorry. So this is going to fail though. Yeah. So the command is explicit. So I'm currently running the Jupyter server as a root, and it doesn't usually allow that. So I'll just do this, copy, and then, so you just need to add this flag to run the Jupyter server as a as a root user. So now my Jupyter server has been started, and this is where it gets interesting. So what I need now to do is, like, I think most what's the name? Most code editors, or this, how would they call it again? Is it code editors or what? I'm trying to find the name. What's VS Code? It's a code editor, right? Yeah, most code editor, if I can call it that way. Yeah, IDE, thank you. Yeah, that's the name I was looking for. Yeah. Most IDE, I think I've not used a lot of IDE. I'm just like a VS Code fan. So, but I think most IDE should have support for this. So what we are going to do is, like, we have this server running, and this Jupyter Notebook server running, and we are just going to connect to it from VS Code. So if I remember the command well, I think it's Control P. You know what? Let's just do this. So after you run this, blah blah blah, I think you press Control P. This will allow VS Code to remain blah blah blah. Yes, it's open VS Code in the blank window in the server, blah blah blah. Connect. This will allow you connect to host. Is it search? I'm not even sure how to do that. Is it Alt P? No. Control. There's a command to. Okay, yeah, okay. It's Control Shift P. Yeah. So when you open VS Code, you just need to press Control Shift P. I think there's a way to, like, manually open this, but for this, I'm just going to press Control Shift P. It's going to toggle this. And what you're looking for, as per this tutorial, is yeah, you're looking for the simple browser show. So I already have I usually use this. So you're looking for this. If you don't see it, you type in simple browser, you just search, and it's going to open it. So simple browser, you click on it, it's going to ask for a URL. So this URL, you come here, you copy this URL from your what's the name again? From your Jupyter Lab server, which is running on DigitalOcean. So I'll copy this link, and then, oh, we need to do that again. So Control Shift P, simple browser, I click on it, then I paste the link here, and I press enter. What this is going to do is it's going to connect to what this is going to do is it's going to connect to this Jupyter Notebook server. And for me to have, like, a nice preview of what's happening, I just need to click this. So I'm going to open it on my personal browser. So I'm going to click that icon. Okay, seems like something is wrong. This is not, something is wrong. Yep, something is wrong. Let's see. Okay, time to debug. So I have this. Did something fail here? I don't think so. Let's just try it again. Control Shift P. I need to copy this. Copy this link. Did I copy? Copy this link. Control Shift P. Browser. I paste the link and I press enter. I'm not sure what this is. Start. I'm not even sure what that is. Stop. I don't think that. Let's see now. Something is wrong. Do I have any? I don't have anything running that should be blocking. All right, now is the fun part. If you have any question where I'm trying to figure out, I'm not sure what's happening here. Maybe we missed this step. Let me just go here again. So open VS Code to a blank window on your local. In the center of the page, there should be a clickable that says connect to. Did I probably that step? Did I miss a step? Connect to, yes, connect to. Oh yeah, we did not connect to the host. Yeah, I skipped something. So when you open your VS Code, we need to first of all connect to this server. If not, it's not going to be able to. Because when I use localhost, it's currently trying to open a server on my localhost, but I have nothing running there. So we need to first of all make sure that this VS Code window is connected to the server on DigitalOcean. So just note the difference here. So when VS Code is like this, it means it's connected to my local PC. Now I'm going to click on connect to and then connect to host. Then I'll put user SSH. I need the IP of the machine. So I'll go here. Paste this here. Now this other window, if you see, check this here, opening remote, connect, establish connection, permission, denied, public key, blah blah blah. I think I closed that. I did not put it right. Connect to that. Yes, connect via SSH. Yep, I need to write I think this is it. I need to write root at this, then yeah, this should work. So observe here, it's trying to connect now to my remote server. And once this is done, it means this VS Code is going to be running. It's going to be, let's say it's going to be, yeah. So see now we have SSH, the IP address of the server. So what this means is that this VS Code window is actually, if I can say it literally, it's actually on my server, but I have access to it here. And then now, once we make sure that our VS Code is connected to the remote server, let me just shift this other VS Code here. So once we make sure that this VS Code is on our server, what you want to do now is to press the Control Shift. I need to copy the link. Remember, we have our Jupyter Notebook server running here. I copy this link. Then on my VS Code server that is running on the server, I'll just come here, I'll press Control Shift P, simple browser show, and then I paste that link I copied, and then we should have this connected now. If I click this, it's going to open a preview on my browser. So I'm going to pause there, and if you have any questions, then let me know. So this is basically what Google Colab provides to you, or even something like Kaggle, because now you have the interface where you can easily create your Jupyter Notebook or like Python script and run the training. And this training is actually happening on this server, not on my laptop or not on my computer or my local computer. So, yep, time for questions. Any questions? I know that was a lot. Okay, probably let's use Kevin's technique from 1 to 5. Drop in the chat how much you understood. And if you're between 3 and below 3, then you can follow up with the question and I'll answer as I'll try to like explain better. Okay, we have 2, 4. Come on, guys. I think that 34 people, let's say 30. So only 2 people. Or should we stop here? It seems like you guys are not following. We have a 3.
I see a 2.
Okay.
3. Okay. It looks like, yeah, it looks like some folks, it's probably understands it, but still needs some time to processing like the information and try it out on their own. I see Sylvester had a question. What GPU optimization for Apple Silicon MSPS MPS is that about?
I'm not sure I understand GPU optimization for Apple Silicon. I'm not sure I understand. I don't really use any like Apple server or Apple computer for any ML tags, so I'm not sure I understand the question. What GPU optimization for Apple Silicon? I'm not sure. Apple Silicon GPU optimization. Is your question regarding have they added like any optimization to make it easy to like train? Or I'm not sure I understand the question. You need to stay connected to the internet. No, the server is active, and see the server is active and it runs for as long as you want. So now we also have this window which is also active, but it's active for as long as there is data being exchanged between this between your VS Code tab and the server. So if something happens that interrupts this connection, this window is going to close, which means that this is going to close, and ideally this is going to close. But if you have any background tags, it's going to continue running because this is on like this server. But if you don't want to, like we are on the upcoming tutorial, we are going to show you how to like run scripts in the background in such a way that you don't need to like always have a terminal active for you to like interact or like to come and view the results. But if you run any script here, this terminal can close, but it's going to continue running on the server. So like if you have a cell that takes, let's say, 1 hour to run, you click, it's going to take like the 1 hour. In case this closes, that is still going to continue running on the server. Is it Sylvester? I'm not sure I understand your question. So is it like pertaining to like GPU optimization? I don't use Apple Silicon for anything other than just like normal editing and just for usage purposes. I don't really use it for any ML tags. So yep. Like I said, feel free to rewatch this. Try to go through the process. I know it's a lot, but when we are going to like provide the training script, this is just like show you guys what you can do, and you can always keep this as something to try later on. It won't cost you a lot, so you can just try it later on your own, or just like watch the video, or just like even go to read this tutorial to understand better. So we are going to proceed. So we have this server running. We have a Jupyter Notebook server which is up and running. We can actually call it a div now because what you just need is to just create a notebook which everyone knows how to like create, and then linear regression. Yeah, and then write your code here. So I have a simple code that we are going to run right now. Need to change this. How do I change this markdown? How do I run this again? Yeah, run it. So yeah, so what we need to do now is we have a simple code that we are just going to try to run. Yeah, I made this summary here, so we're just going to go through this. We need to install PyTorch. The other example is going to have like a better setup, a better like task we are going to be walking you guys through on how to like train a model and export the model, and then the final tutorial is going to show you guys how to use that model. How do we connect to a data set of the virtual notebook? So you can see this tab, right? This tab is actually running on the server, and any folder I created, let's say if you download something, normally you download with wget. So do you know the command wget? I think what can we download here? Let's see. This is public, so I'm not sure if you can download it. Let's see. I think if you copy the link, Is it going to give me the blob? No, it's not going to give me. Let me show you guys something. So if you download anything you run on this Jupyter Notebook, is going to be saved on your server. It means all the files, if you run a command that install, like create data sets and all that good stuff. For example, you guys use Kaggle, you guys use Colab. So you just need to like open the tab and then navigate to the directory where that that file was installed. So I'm looking for a file we can just download so that you're going to see that when we download something, it's going to be in this folder, and you can use this this folder here to like navigate through everything. Unfortunately, it does not allow me to go backward. I'll have shown you. I don't think there's any backward, but if you, as you can see, where did I run the server? Am I at the root? I might be already at the root, so I cannot navigate backward. Well, I'm not sure I don't have tests, but normally I think I should have it. But anything you run on this server is going to be saved here. So if you have access, if your data set is here, I'm not sure how do you connect to the data set. Yeah, you just need to reference the parts to the data set here. So okay, let's do this. I think to run commands you need to do this. So if I put ls, see, like for example, like I've listed the files here. So it's just like any Jupyter Notebook file. And for me to reference, let's say this file, if you see this file here, I just need to reference it as a normal file. If I had like a path to, let's say, a text file or like a folder to like my data set, like this, for example, if I had the data set here, and then I need to like, my code needs me to like set the part of the data set, I'll just use this. If you see, this is like the part to the data set. Or if I do something like this gives me the root directory, the directory where I'm currently at. So for me to have like the path to my data set, the path to my data set is this. Then you add now data set. So this is the path to my data set. Hope that answers your question. If not, let me know. So I want, but I don't think that's necessary. Let me just see if we can just use get where is GitHub? This is not the blob. Probably let's try this. I think it might work. If I use get I think that might work. Not sure. Okay, it worked. So if you see, let's say if you have your data set which is on GitHub or on, let's say, on a website where you want to like download the data set, you just use this command. You probably need to like read more on it, but you just need to use this command, and then it's going to download the data set. And you can see this is what I just downloaded. Now you can just now reference it the way you want to reference it. So we are going to run the example. First thing we need to do is to run to install PyTorch. If I was on my terminal, I would have just wrote pip install torch. But as you guys may already know, on a Jupyter Notebook, you have to always put this. Yeah, go ahead, Joshua. Yeah, go ahead, Joshua. So this command is going to install PyTorch.
Okay, please. I'm not Joshua, but I'll go ahead.
Pardon?
I said I'm not Joshua, but I'll go ahead.
You're not sure of what?
I'm not Joshua.
Oh, sorry. Yeah, but yeah, sorry. Joseph is sorry. Yeah, go ahead.
Okay. So my question: when Colab, see, upload a data set on your Google Drive.
Pardon?
When you are working on Colab,
yeah,
you can upload your data set on Google Drive, and then you make reference to it.
Yeah.
So I'm not sure how you're going to do that on what's the name, the virtual notebook if you've created.
If you need to upload, I think there are ways of doing like connecting these. Like you can connect your notebook to a Google Drive file, or if the Google Drive file is public, you can still use this widget to download it. Else, I think you can just drag and drop. Let's try it right now. So if you can see this my screen, let's try and drop, and I think it should upload. Yeah, it worked. So if you have a file on your local laptop, so for example, see, if I have this and I need to upload it here, I just drag and I drop. Does that answer your
Okay.
question?
Okay, but the data set is a very large data set, so I'm thinking like the drag and drop will not be convenient. So the other option you gave, I think that will be okay.
Yeah, if you have the data set, most of the data set reside on the website. So you just do this, and it's going to be way faster because it's going to be downloading from their server to this DigitalOcean server, which is super fast. So it's not going to be like, you're not going to be waiting for hours because it does not depend on your internet. It's using the server connection of the server. That makes sense. Is there any other question? Yeah, not with SSH. We get is just an utility to download or to download stuff. We get it's just an Ubuntu command. So we get command for download. Yeah, we get this command line utility for downloading files from the internet. So it has like different parameters you can pass to actually download stuff. Where is documentation? I'm not sure. But most data set, I can't find an example now. Most projects you want to run, or most data set, they usually have like, I don't know, maybe they have like an automated, they usually suggest a widget, maybe not. But I know some projects usually suggest like the widget command to just download it. Else you can just like, as long as you have a public link like this one, if you see this is a public link, and then I use widget, it's going to download it. And it's going to be, like I said, really fast. Rather than uploading from your laptop to this, you better download directly from the internet to this. All right, so we have PyTorch already installed. I don't think I need to like talk about PyTorch. Everyone knows what PyTorch is, or am I wrong? Now I'm just going to copy this code. Does anyone, well, I'll just like give an overview of what the code does, just in case. So I'll just paste this code here and let's try to run it and see if it works. Okay, seems like it works. Oh, that was super fast. Okay. So this, I don't know, like this actually the end of the tutorial, but basically what this code is doing is we are just like using PyTorch to train a simple model. Like this is a very, very simple model. So the input, like we are just trying to like, we are using linear regression to like predict a number base. Like if we have like a number X, we are trying to like predict the output Y. And normally it's true, we already know that the relationship here is like linear, but in most cases, you don't know like the relationship that exists in your data set. So usually if you're using a linear model, it means you are suggesting that your model strongly you have an idea that the relationship in your data set is kind of linear. But like I said, this is just like an example. So if you see the data set, which is like something that was just generated, is a sample. If you have 1, then the Y output is 3. If you have 2, the output is 5, which is just basically 1 times 1 plus 1, which is, 1 times 2, 1 times 2 plus 1, which is 3, 2 times 2, which is 4, plus 1, which is 5. And then now we are just defining a model, a linear model. And in PyTorch, this module is like, you're just like, let me show you guys this. So in training a model, you usually have like a network which you use like pass the data for the model to learn the relationship, if I can put it that way. And in this model we have here is just a simple linear model. So it means we have 1 input and we have 1 output. We can have 5 input and 5 outputs. So this is what we are trying to define here. So it means if we have an input which is 2, the output is going to be the output of 2 is 5. And so when we pass multiple data points through that linear model, the model is just going to try to predict what, or come up with the equation to come up with Y. So if you have X, what do you need to do to have Y? And that's basically what the model does. But what you usually have in real life is you have like very dense, deep neural networks that have multiple inputs and most of the time multiple outputs. So they're usually interconnected like this. These interconnections usually depend on like what you're trying to achieve. If you have like dropout or like something, dropout is just means that sometimes you might not want this layer to be connected to this, and you can just drop this layer. And it's like I said, usually neural, like training the model is just like experimenting with different parameters. It's just like when you're teaching your junior, your sister, or like your a very like a kid on how to like memorize. I don't know, if you're teaching a kid how to count, you need to come up with like different ideas that will make the person want to learn how to count or just memorize it, and then you figure out which idea or which approach is best. Some of them could be like you can show them a TV show that shows people how to count. You can show them a cartoon that probably like there's a figure there just counting, and then it's just about like experimenting. So you never know what layer or configuration is going to work, and that's why you usually like there's no rule of thumb on like how to train a model. You just need to like change different parameters, think about it, and experiment and run multiple experiments and see which one gives you the highest performance. So that's basically what this is trying to do. Then we have like a mean square error loss, which is basically I think I have a formula somewhere. So when you're training, you need like when you're passing an input X into a model, you want a way to compare how different, like how that the output is differ from the real result. So here's what I'm trying to say. The mean squared error is just like that way of comparing the input and the output. Yeah, so for example, if you send in 1 into the model and then the model produces 4, so the mean squared error is just like you're going to use this formula and then see by how much 4 differs from 3. A simple error metric could just be like the magnitude of the differences. So let's say if in that case we just do something like 4 minus 3, you take the magnitude, or 3 minus 4, you take the magnitude, and 1, you're going to see that the difference is 1, and then the model is going to try to readjust the parameters to make sure if it's 1, then ideally the output should be 3. And that's basically it. Like I said, we are going to have like a bigger model to train for the next tutorial with like more explanation on how that works. And I think we are going to add like some modality. So we are going to show you how to like manage like data sets that are not just text, or not like that can be probably video, audio, or even like images. So I really encourage you guys to like go through the tutorial. So if you come to like the Notebook LLM, we have some tutorials here. I'll really encourage you guys to go through training your own model. I'll really encourage you guys to go through this resource. It's very, very interesting. Listen to it. You must not understand everything. Listen to it so that during the next workshop, when I'm going through stuff, we're going to be building something different, but the ideas and concepts are going to be kind of similar. So pay attention, like try to listen to what he's saying and note down your questions, so that when we come to the other workshop and you're not understanding something, then you can feel free to now ask your question. And that's basically it. So once I'm done training, if this was supposed to like export a file or like export a checkpoint file, the checkpoint will ideally be here. And what I can do is I can just probably like download it if I need to download it on my laptop. You see, it's going to download it. It's taking some time. I'm not sure why it's taking time. Maybe it has already downloaded. Let's see. Well, not sure why it's not downloaded, but normally this should download. Not sure. But yeah, we're going to like walk you through how to like get the checkpoint file. But normally it's going to be safe here. But we are going to set up a flow that for the training script you're going to be submitting to us, we are going to set up a flow that once your training is completed, is going to like generate a link which you can just click on it and download the the model or the output or the checkpoint file. So more details on that is coming, but basically once you're done training, or personally, once I'm done training, all I need to do is I just go ahead. Do I just close this? Yeah, I just go ahead and close this because I don't still need this window. And if you check, if I refresh this, will it fail? Or maybe not. Seems like the server got disconnected even. So yeah, the server got disconnected. But I think VS Code is still connected. Where is that VS Code window? Yeah, VS Code is still connected. So my terminal got disconnected, but this VS Code is still connected. So that's why I think this is still active. But since I'm done, I can just like close this tab. And I know myself, my data is on this server. And the final thing I want to say is like most server providers for GPU servers, as long as the GPU is active, is going to be cutting you money. So one consideration you need to make sure to do is like once you're done training your model, you either destroy the server, like you delete it completely so that it should not charge you, or some of them have like an option where you can actually like let's say create a snapshot or create an image so that next time I want to come to like create a server, you just need to like recreate it from that image. So let's probably do an example. So about to make it, yeah. So on DigitalOcean, when I take a snapshot, it means it's going to create a copy of all the it's not going to be my server, it's going to create a copy of all my configurations for this server and save it. And then next time, if I come to create a new GPU, so for example, if I come, let's open this in a new tab while that is processing. If I come here and I want to create a new GPU, so what I usually have is like I have like my so I want to create a new GPU. I'll just click on create new GPU and then I come on snapshot. And you see, okay, this snapshot is not supported for this, but normally I have my snapshot here. So I just click on the snapshot and then I just click create. It means it's going to create a server with all my previous configurations. And now I just reconnect and start training. So definitely you want to do that. And yeah, that's it for this workshop. I'm open to any final questions before we close out. That might be a lot, but I think you guys should definitely start thinking about it and start like I think it's good to understand all these so that even if you're not going to be doing this, but you have an idea of what is going in the background. For example, you can create your own Jupyter notebook rather than always relying on Google Colab, and then even get like more power for less money, and then you run it for probably like for 4 hours. So I usually find my time if I'm running a workload on like something like Kaggle, it's very slow, especially if I'm using their free tier. I know you have like 30 weekly, like every week you have 30 hours of some GPUs. So I usually find that very slow. So what I would just do is like I'll just come here, I'll create a very powerful like machine. Like I said, I usually use the H100, so something like this. This is like $3.39 per hour. And then I train the model like a very large data set. And it should take me like between what, depending on like what you're trying to do, but I'm just talking in terms of like prototyping. You want to train something that you cannot easily train on Google Colab, but that's a bit advanced. So you just come here, you train for like 4 hours. That's 3 times 4, which I'm very bad at math, but I think 3 times 4, is it not 12 something? So that's around $16. And then you just shut down the server. And it means you have saved time rather than running a training script for like, I don't know, multiple days, which I know Kaggle caps you at, I think it's 12 hours or something like that. I don't know. I think Google Colab I think you have like, I'm not sure how long Google Colab caps you at, but you see that with this, you can do something a bit more advanced and very quickly. And it's not that costly if you're just like, you just need to like master this process. You start it, you run the training script. Like I personally just prepare my data. I just usually prepare everything offline. Then I test it to make sure I can train it. I just train like on a very sample data set. Then once I'm ready, I just put it on this like server. I just quickly, it usually takes me like 15 minutes to set it up. So if you go through this process once or twice, it should take you like 10 to 15 minutes to just create a server, install everything, and then you just start running, and then you just wait for like 4 hours, then you just stop it, and you have something in model that is advanced, and then you can start showcasing for like your, I don't know, your hackathon project, and so that this is what the model can do at this stage. Imagine if we train now for like multiple hours with more data on a bigger GPU, it can give us this. So yeah, I think I've spoken a lot. So does anyone has any question, any final questions? Yeah, if you can see, this snapshot has been created. So let me just refresh. So I just created a snapshot, which means I can delete this server in peace, and knowing that DigitalOcean is not going to charge me for the server. So I delete it. No more server here. But if I come again and I want to create another server, I come to snapshot, you're going to see that I can click on this and recreate that server immediately with all my data that was there. So if I had a data set or I had something that was already downloaded there, the server I'm creating now is just going to be recreated with it. Okay, yeah, Elibright was like 30 hours, yeah, 30 hours a week. And I think the cap you for a single run, I think the cap you is, I think it's something like 12 hours, if I'm not wrong. You cannot run something that takes more than 12 hours. So final, seems nobody has a question. So final question, like drop in the chat from 1 to 5 how much you understood, and if you have any follow-up question on the data set. Yeah. So what Chris, what's your question on the data set? Josephus, will we go through how to use the efficient net or ResNet model in their respective documentation? No, unfortunately, we are not going to go into that. If we need to like go into like efficient net or ResNet, then it's just going to be like examples from the documentation. So no. And remember, the like those models, we're just like suggesting what is out there. So you can definitely feel free to pick what, it must not be those models. You can pick something else, but we won't be doing like any deep dive of those specific model, because we're just trying to like give you guys like all the tools or all what you need to like do to like create like a production ready model. So first thing you need to like set up the server, second thing prepare the data set, and third thing train. So we cannot like dive really deep into ResNet, because if you are diving deep into ResNet, what about the people that are working on transport? So you really need to like, if you're working on a project, you really need to like start preparing, diving into it and trying to understand it. If you have any specific questions on efficient net and ResNet, I've used mostly ResNet, so you can drop it in on Discord and we'll try to answer it. I think the other mentors also might have like other understanding of like ResNet. So if you have a specific question, try to like take your time, draft the question, drop the logs, probably like what you don't really understand, and we can try to help. If you check the documentation website, you already have all the links you may need. So even like, let's see, even on this, you already have like some suggested data set. And like I said, this is a link to the data set. So you can really start exploring or experimenting with this. But remember what I said, you must not use this data set. This is like a good starting point. If you find another data set, that's perfect. If you want to augment this data set, that's perfect. But you really just need to like make sure you can get your project to a point where, you know, like at the end of the day, it's not about like presenting a final mind-blowing work, but it's actually presenting like an MVP, a minimal version of it that can actually work, or that shows the potential. So like I said, you might use this data set, you might use another data set, even though the data set it's not like large, but as long as you can demonstrate the potential, then that's really great. But like I said, this is the data set. You can start experimenting with this. If you want to search for other data set, feel free to search for it. Okay, any final questions? All right then. I think that should be it. Kevin, May, Regine, any final thoughts, feedback, or something you like to add? All right then. No final feedback. Then okay, guys. Later, see you guys next week for like the next workshop. I'll see how we might want to integrate. I don't know, ResNet. I'll think about it if need be, but mostly it's going to be like showing how to like train a basic model and tips around training it, setting up the training and everything. Okay, bye bye. I'm going to stop the recording.